This is a video on decomposition for the Year 9 science course for the topic Chemical World. This will be the last part of the topic Chemical World. Decomposition is something that we're familiar with in terms of things breaking down. So to decompose means to break down, equals breaking down of something or the decay of something. So fruits that are rotting, that's an example of decomposition. Or dead people, the decay of a dead person, that's decomposition as well. In terms of chemistry, it's quite a simple concept. Suppose I have a substance made of elements X and Y. When it decomposes, I'll get back X and Y. This is a result of the law of conservation of mass, discovered by the French chemist Antoine Lavoisier in 1789. It states that mass is neither created nor destroyed in a chemical reaction, it's only rearranged. So whatever you start off with here, you have to end up with here. Okay, you can't create or destroy mass. Let's do another one. Suppose I've got a substance made of A, B, and C, 3 elements. What does it break down into? It breaks down to element A plus element B plus element C. Let's use now shapes. Suppose I've got substance made of a square, circle, triangle, and rectangle. When that breaks down, I'll get back the square, the circle, triangle, and rectangle. In terms of chemical reactions in everyday life, for those of you that love your soft drinks, whenever you open a can of soft drink, hear a sound, that's decomposition. It's the decomposition of carbonic acid. Carbonic acid is what's responsible for giving the fizz in your soft drinks. It's H2CO3. It's a carbonate. It's made of hydrogen and a carbonate ion, polyatomic ion. That breaks down into carbon dioxide. Okay, that's the gas, that's the bubbling, and water, H2O. Okay, and if you look on the left, you've got hydrogen. On the right, you've got hydrogen. On the left, you've got carbon. On the right, you've got carbon. On the left, you've got oxygen. And on the right, you've got oxygen. So they all add up according to the law of conservation of mass, and the numbers match up. 2 hydrogen on the left, 2 on the right, 3 on the left, oxygen, 3 on the right, 1 carbon on the left, 1 on the right. So it's a very simple concept. Also, you can do this in the lab using calcium carbonate, CaCO3, which is like a chalk looking material. It's basically chalk. It's a white powder. If you put it in a test tube and heat it over a Bunsen flame, it'll decompose into calcium oxide and carbon dioxide gas. When it turns the blackish material, you get the calcium oxide, and the carbon dioxide escapes as gas. This is an example of thermal decomposition. Thermal because it involves heat from the Bunsen. Thermal means heat. Okay, and some substances can only decompose when exposed to heat, such as calcium carbonate. Let's do another example. Suppose I've got magnesium hydroxide, and I'll decompose it via electrical decomposition using electricity. Suppose I could do that. I'll see magnesium oxide being formed, and I have to work out what the other substance is. Well, if I look at the left, I've got Mg, and I've got 2 oxygen and 2 hydrogen. Okay, the brackets means there's 2 with the 2 here. So already I can take out 1 oxygen because there's 1 on the right, and the magnesium can go as well. What am I left with? I'm left with H2O, which is water. That's what's left over here. Application-wise, very, very important in airbags. Big on application in science and teaching. This is where it's very important in everyday life, whenever you're in a car. Airbags. Airbags contain a substance called sodium azide, which looks like this. It's made of sodium and 3 nitrogen atoms. It's literally in airbags. and airbags, they rely on the thermal decomposition of sodium azide. It's a very useful application. And this inflates the airbags, and I'll show you how. So this decays into sodium, Na, and nitrogen gas. It's the nitrogen gas that inflates the airbags, or the airbag in this case. Okay, it's a gas. That's why it puffs up. Okay, gas. This isn't balanced. Let's balance it. NaN, NaN. There's 1 sodium on the left, 3 on the left, 3 nitrogen on the left, 1 sodium on the right, 2 nitrogen on the right. Let's balance. So for the nitrogen on the right, let's times it by 3 to get 6. Put the 3 in front of the nitrogen. Turn the left into a 6. We times that by 2 to get 6. Put a 2 at the front. Okay, the nitrogen gas is the result of the decomposition, thermal decomposition of sodium azide. And amazingly, here's some facts. You only need, so 100 grams of sodium azide can give you 56 liters of nitrogen gas, okay, in under 0.3 seconds, so a fraction of a second, amazingly. So that's decomposition. It involves the breaking down of a substance to give you one or more other substance. I should say 2 other more substances.